All right, guys, let's take a look at this bell work right here. We got determine if it's proportional or not. This table. And so remember, for all these values, we're just going to be comparing each y value with its corresponding x value. Y is in the numerator, x is in the denominator. That's how we find our unit rate. That's how we find our proportional constant as well. So that's what I'm going to do. So I'll create a fraction for this one. And right here, I can see my y value is 30, where my x value is 12. Now I'm going to keep this in fractional form. I think it'll look better that way. But if I do, let's see, I guess I divide those both by 6. Looks like we'd end up with 5 halves on that. So 5 halves. So I guess the decimal wouldn't be too bad right there, 2.5. But let's try the next one, see what we get. All right, so again, my y value here, 45. My x value is 18. And I see these are both divisible by 9. And if I do that, I get 5 halves. Okay, so just between these two, they are the same. They're exactly the same fraction. Or if you change them into the decimals, still the same decimal, 2.5. So let's keep going. If we had found that these two were not the same, then we could say it's not proportional. But since they are the same, so far it is proportional. But let's just check these last two to make sure. I got a y value here that's 50 with an x value that is 20. These are both divisible by 10. And sure enough, we end up with 5 halves. Now be careful, because sometimes we say, well, this is enough to say it's proportional, when in fact it's not enough, because right on cue with what you think math people would do, they would make this one not proportional. Let's check. I don't know for sure if it is or not, but let's check. Okay, so right here, I got x value that's 70 and a y value that's 28. Let's see what happens when we divide these. Well, actually, I'm not using a calculator on this one. I would say they're both divisible by 7, though. If I divided these both by 7, then I would get 10 fourths. Oh, and that is simplifiable into 5 halves. Again, it's 2.5. And so we end up with the same fraction throughout on this one. These all have the same value. With the ratio of y to x on this, okay? So since they're all the same, up here where it says, is this table proportional, I can verifiably say that it is. It would be a proportional relationship. So here's our objective for this lesson. I can solve for missing values in percent problems. Take 15 seconds to copy this down, please. Okay, so we've seen this slide before. We're looking at proportions. Generally speaking, we make these fractions, right? So remember, fractions are a ratio. It's a part-to-whole ratio, though. This is kind of new for us. It usually is a part-to-whole ratio. For example, in a class, you can compare girls to the entire class. The number of girls in the class would be the part of the class, and then, of course, you're comparing it to the whole class. Of course, it doesn't matter what gender you choose on those, but you can make those types of comparisons. Or if you have a basket full of fruit, you can compare the apples, which would be part of the basket of fruit, with the whole the entire number of fruit in the basket. So there can be a difference in the labels that is obvious, but it's possible to compare, for example, boys in one class to boys in another class, for example, okay? Maybe like you consider how many boys are in the first PE class to the number of boys in the second PE class. That's a part-to-part representation or fraction, and again, we can find proportional values for those as well. The important thing here is if we have labels, if we're looking at word problems, we're looking at labels inside our proportion. We need to be consistent with where those labels are. That's going to help us to solve these proportions. But overall, the main thing that we need to understand that a proportion is comparing fractions that are equal. So we've seen this example before. You can have 1 out of 2, like with the sandwich, right? You can have 1 piece out of 2 pieces. Or if you split it up further, you can have 2 pieces out of 4, maybe 3 out of 6, or 4 out of 8. These are all equivalent fractions, and so you can compare them side by side. You can compare all 4 at the same time, but they are proportional. If you wanted 4 pieces out of 8, you're not getting any more sandwich, you're just getting smaller pieces. So that's what the denominator tells us. Generally speaking, it says we're changing the sizes of things. Again, in this particular example, we're changing the size, but as the pieces get smaller, then you get more, so that you get the same amount, even if the pieces are bigger. 2 pieces, you get 1. So I'll stop with that right now before it becomes too confusing. But percents are a comparison of out of 100. Okay, and generally speaking, in most countries, they view this as 2 words, per and cent. If you're not familiar with the word cent, for my generation, you kind of looked at that like pennies because it was considered a cent. It's 100th. Okay, so it's per 100. So it's out of 100 again, meaning you are going to divide by 100, which is why as a fraction it's always over 100. Not that it's over 100 value, it's just that as a fraction it's over 100. Okay, so the 100 here represents 100% or all of something. Again, that would be like comparing a part to whole ratio right here. So that'd be like a part in the numerator, and then the 100% would be the whole of whatever you're talking about, like a class. Okay, so these fractions compare part of something to something else, especially when you make them equal to something as well. Okay, but again, the 100 really is a percentage, and so the percentage that's given, generally speaking, is the numerator there, because that is the percent per 100. It's something out of 100. All right, so real quick, percent form to decimal form and decimal form. So we know that decimals can be changed to percentages to decimals. Percent is a number that has already been divided by 100, and that's true, meaning that you're looking at the second place value, right? Because remember, this is per 100, and that second place value right there is what we call the hundredths, with the TH there at the end, place value. Okay, so we're looking at the hundredths place value. That tells us how many hundredths there are, which would also be the same thing as asking how many, what kind of percentage we're looking at. Okay, that may not make sense, and it doesn't matter if it does or not, as long as you understand that a percent is a number that's already divided by 100, meaning that if you have a percent, something like, let's say 63%, okay? So 63%, and there's our percent symbol. Maybe I should have emphasized that a little bit more. A percent symbol is, you got 2 dots and kind of the slash right here. And I think there's some deeper symbology here. The 2 zeros indicates that you're looking at a 100, and this kind of slash right here tells us that it's out of 100. It's kind of like the division sign, okay? Maybe that helps, maybe it doesn't. But again, what does this mean as a decimal? Well, it's the same thing as saying, well, you got 63 out of 100 as a fraction, or in other words, you have 63 hundredths, which would be 0. We need a 63 hundredths, so 63, and here we can see the 3 in the hundredths place value, so 0.63. Some people say it's just like moving the decimal 2 times to the left, and if you can memorize that, that's fine. But if you just remember that it's 63 over 100, then that's going to give you the same decimal answer anyways. So a decimal can be changed to a percent just by finding how many hundredths. That's what I was talking about up here. Meaning if you start with some kind of decimal, very common one, 0.25. Again, we would say it changes to a percent. How many hundredths are there? And right here, well, to determine how many hundredths, I just got to find the hundredths place value, which is where the 5 is. And I can see that would indicate there are 25 hundredths. So this brings us, 25 hundredths, meaning that'd be 25%, okay? Well, is it possible to have more than 100%? It is. For example, if I had, let's go and change that 0 in the ones place value there to, what the heck, let's make it 2. Okay, well, then you can see that we'd have to read this whole number without the decimal, it's 225. And so if you saw this number without the decimal, 225, well, that's what it is, 225. And again, I kind of changed the problem there, but that's 225%, okay? Or 225 hundredths, however you want to look at it. So that's a nice quick intro for percentage or percents. But then we have what we call the percent proportion. So since there is a percent in these proportions, one of the fractions is always out of 100, meaning that when we start these out, you're not going to see that other stuff, meaning you can have two fraction lines that are equal, just like we would expect from a proportion, but one of these is always going to be 100. And it's always in the denominator because, remember, the percent is always out of 100, okay? And again, it is okay for the percentage to be more than 100. I don't think we're going to see any examples like that, word-type problems where it would be necessary. And no, I'm not talking about someone that says, I'm going to give 110%, which is, I guess hard to quantify, but like making money, right? You can say, well, I made 150% more than I did last time, whatever that means. And then you can have more than 100%, okay? But just the idea that you understand how to set these up is important, okay? Now, the percentage in the problems that we're going to be seeing is usually very clearly spelled out. You'll see the percentage symbol, or they will say that it is a percent. We know that value always goes above 100. We're not looking to change that value to a decimal. It is already percent. Just get rid of the percent when you put it up there, okay? But again, the percentage always goes above 100. The other two key words we're going to look for is and of. The number that is considered the part. The number that is of is the whole. Okay, now that may not make a lot of sense right now, but we can fill these in. And as long as they give us two of these values, we can solve for the third with one of four techniques. And we've seen one already, although we haven't really explicitly gone through it too much because figuring out some of those values is easy. You can look back at the last unit if you need a refresher on that, but we're going to go over how to do that with some of these examples. So here's our four main methods for solving for unknown. Now, we've pretty much gone over scale factors. We've seen some principles of equality. We don't generally use principles of equality when solving a proportion that's already set up, though, or even one that we have to set up. But again, one of these three values is going to be unknown. For a percent proportion, that denominator will always be 100. But we can use scale factors, meaning that we can enlarge or simplify a fraction to get to another one, right? For example, if I saw a 10 right here, let's make that easy, then I could say, look, I know if I wanted for some reason to go in this direction, I could say, look, I'm going to take 100 and divide it by 10 to get that 10. That means I would have to divide the numerator by 10 as well to get an equivalent fraction, which may give me a new numerator, okay? So scale factors pretty much tell us whatever you do to the numerator or denominator, you're going to have to do to the other. Okay? Kind of like what we would expect with principles of equality, right? Because principles of equality say, and this is more related to the equal sign, whatever you do to one side of the equal sign, you must do to the other side, right? So we've seen those before. Generally speaking, with proportions, we're either using we would generally use the multiplication principle of equality. So whatever you do to one side, multiply to one side, you'd have to multiply it on the other side. We do that to get rid of denominators. I'm going to ignore that for now, but we have seen problems like that. For example, if we go back, you may remember problems that were something like this. X over 5 equals 2, and then would say, look, again, I would just be I'm going to use a different number than 2. No, 5. So I got to multiply both sides by 5 here like this to make that a phantom 1. Then I get x equals 10. So we can solve proportions the same way even if we end up with a fractional type answer. That's okay. We'll get into cross multiplication and fish method. They're kind of algorithms, processes that we have to memorize, and if you can memorize them, that's good. Fish method, by the way, to me, it's a more simplified form of cross multiplication, which you may have heard of. Cross multiplication is just where you're cross multiplying those two values and then these two, and then setting those products from the multiplication equal to each other. Again, you're going to have some kind of unknown, perhaps, like this one. And then you're going to have to use a principle of equality in the end anyways to solve. Fish method, again, it's related to cross multiplication. You multiply, divide, and that'll give you your answer. But it depends on where the x is. That is going to determine how you set those up. So we've seen principles of equality. I'm not going to go into that. Scale factors as well. I'm not going to worry about that too much because, generally speaking, most students prefer either cross multiplication or fish method. So that's what I'm going to show, and then you can determine which one you like the best and use it. Unless you remember scale factors or principles of equality, you can always use those. It's really up to you. I don't really care which method you use. Use a method that works and then stick with it. Okay, but again, first we got to be able to set these up. Now, remember, I'm always going to put 100 right here in my proportion. And just setting these up, I mean, you may have to draw these out yourself. But right off the bat, we see a percentage. What is 675% of 96? Well, they've given us the percent. That's very generous of them. And the percent is 657. So I'm just going to write that in as my numerator over 100, right? 675. Whatever I said earlier, I meant 675. Now, remember, we have to pay attention to the words is and of. Now, right here, it says of 96, which tells us that the 96 has to be what we consider the whole value. And just from the setup that we've seen earlier, I kind of stuck this on the slide. We can tell the whole value is always in the denominator of the other fraction. So this is going to be 96, which means that we don't know what this part is right here. We've got to figure out what that is. So for this example, I'm going to use cross multiplication. Okay, so that means that with cross multiplication, I would take these two values, 675 and 96, and I would have to multiply them. 675 and multiply it by 96. I'm not going to evaluate that yet because that cross has to equal the other cross between these two. Okay, so that I'm just going to write it as 100 times x. Now, we have an equation with a variable in it. That's okay. That's what we're solving for, the x, the part right here. Now, that doesn't mean you have to write in your answer x equals. We're just going to circle the number. We put in the x. It wasn't there for us. So, but before that, I gotta multiply these two out. 675 times 96, big number. And yeah, I got 64,800. Again, just please use a calculator for that. There's no reason to try to do that by hand or in your head. But now I got an equation. Remember, with these equations, pretty much the last thing I want on this, I don't want 100 x's, I want 1 x's, right? So in order to solve this, I would have to take that 100 and just divide it by itself. That's how we make ones with the division principle of equality generally. So I'm dividing the other side by 100. Put that in the calculator, you're going to get 648. Okay. So in other words, what is 675% of 96? Well, we just found it. It's 648. And really, that's the only answer we need. Again, we don't need to write the final answer as an equation. We put the x there. They didn't. We were solving for x, though, on our own. Really, the number's all that we're concerned about there. So on this one, 465 is what percent of 750? I'm going to use cross multiplication on this one. I'll use what I call fish method on the next one. So we're targeting cross multiplication here. But I need to be able to set up my proportion first. Remember, it's always out of 100, just like we see up here. This one, they did not give us the percent, which indicates that we're going to solve for x right here, because that's where the percent is always above 100. So, again, we got some key words, though. It says 465 is what percent of 750? 465 is, well, the is the part. That's our numerator, so I got to put a 465 there in the numerator. And it even says of right there. That's the key word. Of is the whole. And so we got the 750 in the denominator right there. Okay, so this at least sets it up for us which then will allow us to use cross multiplication. On my first cross right here, I got 750 times x, and I'm putting the 750 as the coefficient of x. Remember, that's the number being multiplied by x, just so I can make this look a little bit more familiar. But then we got on the other side there, I got 100 times 465, which isn't too difficult of multiplication, but that'd be 46,500 right there, okay? And this all equals the 750x. Well, the last thing I'd have to do to solve this one, just like you'd expect, and we are going to have to put the label on here of the percentage. So I'll just tack that on now so I don't forget. And you'll need to remember to put that into the computer when you find your answers as well. But what I want out of this is 1x, right? So I'm going to take that 750, just divide it by itself. Same with the 465, though. If I divide one side by 750, I must divide the other side by 750. So 46,500 in my calculator divided by 750 gives me a pretty nice answer there, 62%. So what percent of 465 is what percent of 750? It is 62%. For this one, I'm going to set up fish method, and let's start with a proportion. This one didn't give us the proportion. Remember, the first fraction, I always make it out of 100, although you can make the second one out of 100. Doesn't really matter where you put that, as long as the 100 is in one of the denominators. Well, it says 49 is 35% of what number? And the first thing I notice on these is the percentage, because it's just so easy to see. It's 35%. Percentage always goes above 100 every time, no matter what. And then it says right here, 49 is. Remember, the key word there is, which means we're looking at a part, which means we're looking at the numerator of the fraction. It even says of what number, which means we don't actually know what that whole value is. Okay. Now, for fish method, because that's the method I'm using. For fish method, we set this up. We have 4 values, right? 1, 2, 3, 4. Fish method will always be multiplication, then division, and then you got equals. Now, if we do this right, you should always end up with it equals the x. We do not want the x in the operations, meaning that this becomes a direct calculation, which we can just plug into the calculator, okay? This is how it works. With fish method, you always start where the variable is, okay? Or the unknown. And in this case, we're starting with x. So I'm gonna put a dot there with the x. That's where I'm starting. And now that I know where I'm gonna start, I'm gonna make the fishtail. Okay. Well, when I say I'm making a fish, it's a fish method, but it's not like a super artistic fish. You got 2 different types of fishes that you'll ever use. You got a fish that faces to the right, and you got a fish that faces to the left. That's it. Okay, and if you want to be artistic about it, that's fine. I'm a math person, so I don't really give a crap about that, okay? So the fishtail, we can see for both those, just a straight line. So from here, I'm going to make a straight line straight up and down. And I see that the first number I encounter there is 49. So I just plug in 49 as the first number in the set. Now I'm going to cross over and make kind of the body of the fish. And I see that the next number I encounter is 100. Well, then I'll swing this up to make the head of the fish. And I can see that the next number I encounter is 35. And I can finish this off at X, right? Well, there's our fish. And, some students like to put a nice little smiley face on there, and maybe they put a mouth on it with some teeth, and I don't know, then it gets kind of angry. Whatever. But all I'm going to do with this is I'm going to plug this into the calculator directly, right? 49 times 100 divided by 35. And again, this is kind of a shortened version of cross multiplication, because you essentially do the same thing. I get 140 is equal to my x on this, meaning 49 is 35% of what number? It's 140. All All right, William has a mask collection. He keeps 108 of the masks on his wall, which is 36% of the entire collection. So this 108 right here is 36% of the entire collection. So what is the total number of masks in William's collection? This word right here, total, indicates that we're looking at the whole value right there. So let's go ahead and start our proportion round. We got two fraction lines that are equal like this. And remember, it's always going to be out of 100 with the percentage always over 100, which was given to us as 36. Now again, since we're using the percent proportion, there's no need right now to change that into a decimal, which could be important later, but for now we're good. So the whole value, right? All the masks that William owns, we don't know how much that is. That's the whole collection. But what we do know is that the part of the collection that's on the wall is 108 right there. So I'll put 108 here as well, okay? Now, the first two examples we did with cross multiplication, so this one I will do again with fish method, okay? So again, we got four values. It's always multiply and then divide, which will equal, it should always equal the unknown, which in this case is x. Now the x is in the same place, so when I perform my fish method on this one, it'll look something like this. Now let me up, and then I'll come right back around into the bottom right there, okay? So I start with the x, and I always start where I will end. So I come up here to 108 to make the tail. That's the first number I encounter. Then I cross down to 100. That's the next one I encounter. Make the head of the fish, which in this case is 36, and finish off at x. And this is just something I can type into my calculator right here. So when I put this into the calculator, it just shows me that the x value there, this ends up being 300, okay? So the answer is going to be 300, but it's not actually just 300. Remember, there's a word problem right here that we're doing. So we need to make sure that we label the answer with appropriately, which in this case is masks. So it looks like William has 300 total masks. That's a lot of masks, I guess, but he's got 300 of them. Only 108 of them are on the wall. At a sale, coats were sold for 52% of their original price. If the coats originally costed $250 each, how much did a coat cost on sale? Well, let's go ahead and set up our proportion, okay? So remember, that's two fraction lines that are equal. And since this is a percent proportion, we know this one's out of 100. Okay, now in the future, even if we don't know it's a percent proportion, but they give us a percent, we can make a percent proportion out of it. We just know one of those values is going to be 100. Well, they gave us the percent, 52%, and that's of their original cost. Well, the original cost is going to be full price. Okay, so original cost here, when it says that, that's full price. Okay, so we can find the full price here, $250 each, or another way to look at full price would be the whole cost. And I don't know if that helps, but again, there's several different ways you can look at full price. Just the whole amount, which is showing as $250. We're looking in this case then for that partial amount, because again, we don't know how much, this is how much they're sold for. That's the sale. Well, what we need then is the sell price, and that's going to be X for us, okay? Now, you could use cross multiplication, which is highly desirable amongst students, but for this one, just to show something just a little bit different, I'm going to use fish method once again. And so you have the four values, 1, 2, 3, 4, and it's always multiply and then divide, then equals. Excuse me. But on this one, you'll see that in order to make the tail, again, you always start at X because that's where you will end, but the tail is a straight up and down line. So I go down to 250, so that's where this one's a little different. I come up to the 52 to make the body and then the head, which is 100, and I end at X, which I should always end where I start, and that should always be where the unknown value is. So now that I have that, I can go into my calculator, 250 times 52 divided by 100, enter, and it shows me that the sell price here will be 130, but not just 130. Make sure to label this one also as $130. So it'll be $130 of sell price, where the original was $250. That's what you get. That's 52% of the original cost right there. Pretty good deal. All right, so there's our lesson. There's our objective. I can solve for missing values and percent problems, which hopefully we now understand how to do, and also how to set up those percent proportions, which then we solve. So you have 4 methods. We've gone over 2 in previous lessons. Today we focused on cross multiplication and the fish method. So hopefully one of those really works well with you. I'm not saying they have to like them, because it is math and most people don't like math. So if you didn't like it, that's okay. You just have to find one that works for you. But you should now be prepared to do the assignment. So go ahead and grab a computer. This is 9.1 on Canvas. Get that done and get it in so that you don't have to worry about doing any work at home, okay?